Hello everybody, my name is Kyle Davis, and today I'm going to make a video all in one cut, hopefully, we'll see. I just kind of like videos that are more personalized and with a little bit of errors and less jump cutty, and I don't know, it just kind of brings me back to an earlier time in YouTube when things were so not like digested and refined, and so maybe I'm an outlier in all of this, but anyways, today's video is going to be looking at GitHub and GitHub in R and GitHub for maybe new users of data analysis. This is something I'm really passionate about, something that I've learned over the last couple of years, and something that I think that I'm pretty good at this point. So this video is just going to be about all of the different things just to get you started, all of the content all in one place. I'm going to try to organize it a little bit by sort of like flow of things and like the process in which you may do things. But ultimately, if you want to learn something new, you may want to look in the description because there will be different chapters where you can scroll around and yeah, learn new things about GitHub and GitHub in R. So let me go ahead, share my screen, and talk a little bit about GitHub, a little bit about R, and why this is just such an incredible thing that you should be using. And yeah, maybe, I guess my goal is at the end of this video that you feel inspired to start learning more about GitHub and R, and yeah, maybe convince other people you work with to move away from things like shared drive or saving all of your files on SharePoint or saving all of your files on your personal computer, because this is just a way better way to do things. You got to hear me out. So let me introduce you to the world of Octocats and GitHub, and we'll get started. Let me hit OBS transition. Fancy. Look at that fancy transition. Okay. So this is GitHub. Welcome to GitHub. And personally, this is my page here. So my GitHub page is Kyle Davis GitHub. You can see here that, you know, background about me. I have no followers, so click the link in the description below. And surprise, this was all a trap just to get you to follow me on GitHub and follow all the things I'm doing. But I've started a lot of really cool R things, including like the Wes Anderson color package and a lot of what Hadley Wickham's doing and like code books. And so feel free to scroll around those stars because there's a lot of cool stuff in there too. But enough self-promotion. This is, let's go right to self-promotion. So on my front page, I have a README, which is a little bit about myself, the ways to connect with me, and languages and tools. This is a really cool thing I figured out, which is you can insert a markdown file as your like personal page README if only you set up a repository called what your username is. Wow, I really need to take a step back. So what is GitHub? GitHub is essentially an online cloud storage system that is interconnected with a lot of different programs, including SAS, including R, including Python, including a lot of different things. But you can even upload like Word documents and PowerPoints and things to this, no problem at all. And it's basically a cloud storage area, which is really convenient. It invites a lot of collaboration because you're able to have multiple people working on the same document at the same time. Through things called like branching, where you would branch off into a different path. And yeah, this is just really secure. Your work probably has an enterprise account where it's just siloed to keep in all the information just for your own company. But even outside of that, personally, you can share code extremely easily. You can create repositories and upload seamlessly. It creates a really fantastic workflow because you don't have to deal with a lot of different files and things. I'll show you an example later when I hop into R. Surprise, that's coming. But yeah, so let me just review everything that's on the website and we'll kind of talk through everything. So basically, I have a profile page, but most people don't. I have a README document, but most people don't. And then here are all my pinned repositories. I have a couple, including my graduate methods handbook, which is a book I'm writing detailing all of the different methods at OSU that I took and a little bit before, all combined into one is sort of like a primer for social scientist graduate methodology, which is kind of cool. I have my Intro to Networks with R series that I'm recording right here on this channel. All of the documents for that's being uploaded here. I've done some work on Krippendorf's alpha. I'm not going to get into what that is, but also LaTeX. I have a lot of skills in LaTeX, so I uploaded a lot of templates here. You can see all the contributions are mostly do my work on the weekends. Most of my work at my job is contributions here, but I don't have the two accounts merged together because that one is on an enterprise account and mine is my own personal account. There are ways to merge both of them together through something called GitHub Connect, but my company doesn't use it. And essentially that's your full profile. You can go back in time on people's profiles to see when they uploaded. So for example, I did basically nothing in 2020 or 2019 looking for jobs. In 2018, I did a bit. And in 2017, I had like maybe a month and a half period where I loved GitHub and was doing a bunch of coding and uploading and stuff. But doing a little bit more consistently going forward as of today. So that's my profile, and that could be your profile if only you sign up with github.com and get yourself a profile. Not sponsored, by the way. I just think this is a great technology. If you already know about GitHub, here's a fun fact. Look up what, or maybe I'll remember to include it on screen. Let me write a sticky note here about that. Git on screen. I'll include on screen the origin story of GitHub, which is pretty lewd. Yeah, really interesting origin story of how Git got its name. But yeah, enjoy that. Feel free to pause and read that. But once you have a profile, you can go up here to the top right and click on New Repository. And this will create a new online location similar to a folder in a computer where you're going to start storing all of your information. Now you may say, this sounds a lot just like a shared drive. This sounds just a lot like having a folder on my computer that I can store all my stuff, and then I can just give access to somebody else, and somebody else can come along and update the contents in the folder. And you'd be right. It's pretty similar, but the main differences is that GitHub offers cloud storage and cloud security. I can't tell you the number of times that a shared drive went down and I couldn't log in to access my information or like do my job. But GitHub basically circumvents that because I'm only logging into R or SAS or Python, whatever program you choose. And I'm only working with my files and information in that platform. So it's a lot more reliable. But also, it's a lot easier to work with others because you can code on the same document at the same time and then push and pull updates. So maybe something like this sounds familiar where you have files on your computer, but it's like my resume V1, my resume V2, or like coding project this date, coding project this date. Well, GitHub has built-in version control with your own comments and documentation as you go along, which is just super seamless and just makes a ton of sense. So, for example, if I go to LaTeX templates, if I go here, you can see that I have all my files here. So again, I just clicked on a specific repository. So now we are on Kyle Davis GitHub /LaTeX templates. Here I can view all the different files. And by the way, some of these are probably broken. It was 4 years ago. Give me a break, all right? But I include some tags about what this repository is about. I had one official release in 2017, which was the release of all of these templates that you could use to learn LaTeX and basically make a slideshow that's code-based as you go. And so what's nice is that this folder, or all the contents of this, is selected. I can select what goes in, I can select what doesn't go in, and so I can cut out a lot of noise. So for example, if I didn't want the bibliography here, I would add this to a Git Ignore, which a Git Ignore is a simple text document that lists all the different files that you want to be ignored when you go to ultimately push to GitHub. So GitHub won't include the bibliography file, for example, if I didn't want it to be published there. You'll see some examples of this later. But you can see that the language was written all in LaTeX or text. And there is a README file attached, which has a brief table of contents, as well as some images, what's all here, contact information, examples. I included here a table of different social science journals that accept LaTeX or not. Yeah, so this is just a super, super organized, well-documented, process-controlled way of storing your files, which is leaps and bounds better than just having a shared drive or just having a SharePoint. SharePoint technology is nowhere as integrated with this. And also, GitHub is just the #1 cloud document storing platform out there. Entire websites are built off of GitHub. Entire companies are doing their data analytics and uploading and downloading from, or pushing and pulling from GitHub. This is just an industry standard leading technology that is ever expanding. And also it's a great just professional network of connecting in with other people that are working on projects similar to your own. And it's very easy to hit this explore button at the top and explore different opportunities that you may want to get involved on as a contributor, and then happen to have your work shared around. It is the hive mind defined. Yeah, it's just beautiful. So a couple different things that you can do as you're looking at the files here. For example, let's go ahead and go back, because I'm going to be showing you in R a different example later on, which is my graduate methods handbook. So let's swap examples over to this one. So you can see this one has a Git Ignore, which there's quite a few files that are ignored. Not all of them. There's a couple files here I probably could ignore, like the concordance file, but some of them are in here. You can see this one's mostly written in LaTeX as well as R. I mean, it is a handbook after all, so most of it's going to be document creation. But there's a little R file for some data testing. A lot shorter README. I need to expand this, but it has my email address and some contact information if you have any questions about it, as well as relevant tags. So let's go ahead and click on, for example, the RNW file, updated 2 days ago, and we're actually going to update that this video. So if we click on RNW, which an RNW file is essentially a LaTeX-based R file where you can write documents and publish them online. So yeah, through things like Bookdown and other things. I haven't gone that far with this yet, but actually there isn't even a release for this yet because it's still very incomplete. But here you can view all the code that's in here. And it goes on and on and on. You can see the scroll bar is like microscopic. But this has the full book that I've been writing, including some contact information. So a couple different things that you can do once you view a specific file. You can view the raw version of the file. If you have permission, you can edit or delete it, as well as open it on your GitHub desktop application if you have it. You can see when it was last updated. And then this here is this like series of numbers and letters is like the tag that it was released in. So if I click, and you can see the number of contributors, which is just me. But if you click on blame, now this is one way of understanding this is like who to blame for a chunk of code getting changed. So for this, I only have one contributor, just myself, but it could be multiple people and you may not know who the heck made a change to your code that's causing it to go wrong. So this is who to blame for it. Other people have tried to redefine this as praise, to praise who made something right, glass half full, right? But judging by the origins of GitHub and how it got its name, wouldn't surprise you that it was blame. So let's click this. And we can see here all of the comments for the specific rows or the specific lines of information that are in here. So these are all the comments just for those code chunks, which is just way more commented and organized than many of the documents that you would have in a shared drive or on your personal computer. It's really, really nice. You can, if you scroll over here, you'll see the numbers of additions and subtractions that I had with that particular update. So you can see in this update 3 years ago for these lines of code, which I probably included my graphics path, I added in with that 23 additions and 31 subtractions from that overall commit. Now, a commit is something that basically you're committed to pushing or committed to updating. It includes like a message, which is what you see here, minor reorganization, initial setup. So this is, yeah, these are the notes that get included with your update as you push things to GitHub, which is pretty cool. It's a great way of commenting your code as you go on. You can see here I included my LinkedIn information along with the note here. It's been a while since I last updated this project, updated contact information, which had a lot of subtractions because there was a lot of useless stuff up there, including a bunch of packages that didn't work anymore. So yeah, this is, have I sold you on this yet? It's a pretty organized, well-documented, process-controlled way of uploading files. So you can see there's a lot of cool functionalities that you can have with GitHub, but how do we use it? What's going on? Maybe that's why you clicked on the video. You already knew about all this, Kyle. You skipped all of this up until exactly now, when we're going to talk about how to commit and things in R. When we pull open R, and so if we're looking at R, this is my R interface. I use RStudio have a lot of different settings changed, but yours is probably something like this. If you didn't know, as you're writing a document, you can pull out the table of contents. I found this out just the other day through clicking this button here. But yeah, so I've pulled this out. And in my dyads and triads section of my document, I noticed that there's an error. And the error is simple. Here in this calculation, I'm not going to go into what it is. Feel free to watch the network studies feature on this video. There's a whole series going on about network analysis. But I saw that in that line of code, I was doing matrix multiplication and not regular multiplication. How dare me? So the number that you got from that calculation was completely irrelevant and wrong. So I'm going to make that change. And just that change. So it was a change to probably 2 lines of code here. And so let me go ahead and save that change in this document for the RNW file. And we'll see that once we made that change, a document popped up here under the Git tab. The reason why this Git tab is here is because I'm working in a project in RStudio. And so you have your projects in the upper right-hand corner that was initialized with a repository or a GitHub repository in mind. Let me see if I can actually go to that. So if I click on New Project, it'll pop up a screen here. And you'll want to click on this button that's called Version Control. And when you click on this, it'll say, hey, initialize this with a GitHub repository. And when you do this, this is where you'll enter in all that information that you did earlier online in the online portal here. And you click on this and initialize a new repository, which is usually just the URL. But you may have to set up some settings about your account and maybe an SSH ID, and then eventually you can have them synced up. Well, not exactly synced up yet, but you'll have the information in R connected to the information online. Where you actually sync things up is where you pull information. So let's say that you go online and you initialize a new repository with a README file that I talked about earlier, and maybe even a Git Ignore file. So you have those ready to go. You haven't even touched R yet. What you may want to do when you initialize a new project here, by again going up to the top right, New Project, Version Control, GitHub, what you may want to do when you enter this repository URL and your directory name of where this file is going to be, after that stage, what you may want to do after you set up this project is to pull. And polling is essentially pulling in the information that's online that others may have changed. Maybe you have a bunch of different collaborators on a particular project, and they've been working, they were working on Friday afternoon, and now it's Monday morning. So you need to go in and pull all the updates. If you click pull from after setting that up, it will pull in that README file, that Git Ignore file, and some of the other initial things. So if you forget to do that stage, R is going to shoot you a message about it. Don't worry. And it'll tell you that you may want to pull before sending updates. But here in this example, I made an update, and I should be up to date from what is online. So I don't need to pull, I think. We'll find out. But now the next stage is for me to click that little fancy box next to R and W. Now I'm going to click on Commit, which is what I talked about earlier as the notes. And you'll see here that it did update just one line, which is what I removed a comment, and then also I changed from matrix multiplication, where you have a multiplier symbol surrounded by parenthesis signs, to just regular multiplication. So I'm going to include a commit message because I'm a good person that says changed matrix multiplication to regular multiplication, which is the point of this section of analysis. If I can spell. There we go. So fantastic. This is a really detailed commit message. Most of them are very short or coded. So commit. Great. And you see it all cleared out. And now my branch is ahead by 2 commits because I made 1 commit before starting this video. But if I'm done there, now, since I'm ahead by 2 commits, it's best for me to push. And it's going to push it to the master branch, which is the head here. So now the head is the master branch, and the master branch is the latest document, right? If if you're familiar with making your resume, it may be the version 6 on your computer, which is the latest one. But here we have pushed right to the straight head one. Now you may be off in a different branch from somebody else. Let's say you got 5 people on a project and you're working on a particular portion and you're just going off on your own trail to kind of explore something. You may want to create a new branch and then label what that branch is, and then go off on a different direction. And then later on, you can merge that branch back to the main master file, and that way you have version control sort of interlaced with different members of your team. But for this file, it's just me working on this document, so I am just always pushing right to the master branch, right? I don't really need to branch off in different ways when that main thread is the main thing that I care about. So let's say that we wanted to ignore something along the way. If I had a file here, I could select it. Like, let me make one more edit. So I'll save just me deleting a space just to populate something here. What I could do is select this and have it be this light gray color. If I click on more and click on ignore, you'll see that it'll add it to the full list of things that I'm ignoring in the file, which really is all a git ignore is. It's just a text file with a bunch of different rows of things that it wants to ignore. So every time it sees the table of contents for my methods handbook, it's just going to ignore updating that. It's not a necessary file because it's baked into the RNW anyways. Or like R data, my R history, the R project itself never really needs to be published. So I went through and added a bunch of different things. Some of the figures, went through and added a bunch of different things here to ignore. In this case, I don't want to ignore the RNW. That's kind of one of the main pieces of this. So we'll close out of that. But yeah, that's how you would ignore a document. Let's see what's next here. So let's say that this is all good. You've pulled in new information, you committed your changes, and then you've pushed them to the new repository, ignoring some of the files that nobody really cares about. I think this is good for data security because you can ignore the different Excel files and things that has perhaps IID or individually identified, I forget what IID stands for, but it's basically individual data of somebody else's. So you don't need to really publish that online. You can ignore that. Whereas in a file, you would have to like right click it, set it as hidden, but then other people can come along and unhide it. Maybe you'd set the security settings. It's okay, just ignore the file and then it'll never get published. And it just remains on your computer, which is a little bit easier. You can see here we have a mountain of files for this methods handbook, but when you go to online, which, wow, did I really close GitHub? But when you go online here to GitHub, you'll see that it's much more concise and I'm not publishing any data or anything, even though I may be using it in the handbook itself. So a little bit more concise here. Yeah, so after this, you may notice that there's a big bar up here. So let's say that you're now integrated with GitHub and you're still not really sold on if this is something you need to be doing. You have a bunch of other options and these are ever expanding. You have security options. You can get insights about your information and who's visiting and who's not. You can set up actions like action plans. You can convert multiple repositories into a project and have a whole team working around a project. You can monitor the number of pull requests of your information, as well as set issues. So if somebody has issues with your code or issues with your information as they go through it, and they let's say somebody else came along and spotted that that matrix multiplication just does not make sense to be there. Somebody could have wrote an issue about it, and then I can go in and review what issue they had with my code, and then correct it and tie the commit to that issue before sending an update, which is just awesome. It's really, really organized process control information here. Let me see if there's anything that I'm missing, but I think that that is a pretty good summary of GitHub in R. The 24 minutes, man, I've been talking for a long time. I need a drink of water after this, but I feel like that is about everything. There's a couple different places where you can access all of this push and pull information. So you can access it here through the Git icon, I guess I'll call it up here, where you can push and pull information. You can commit, you can view the methods handbook on GitHub, which I guess I did that the long way by clicking on Chrome and then going there. You can also reset up your project if you're having to troubleshoot some stuff. But I usually use this Git tab over here, which will populate once things are set up pretty well. And then another way that you could do this is through your terminal, which GitHub, I want to say recently, but it's actually been a couple of years now that GitHub added this terminal feature in, or not GitHub, RStudio added this feature in. I think it was the same time that RStudio launched this modern sort of dark mode format. Thank God. But here you can see that on my laptop, I'm connected to my master branch. And if I wanted to pull or push, I could from here in the terminal. A good thing to know is that if R is still just giving you a bunch of problems about pushing, and it's like, nah, the versioning's off, you can always do /f or -f, and that will force the push. Also, just Stack Exchange can help a ton with some of that code if you need to go to the terminal to override any of the settings that are here. So yeah, those are all of the good features of using GitHub in R. I think going forward, the workflow looks something like this for our users. Perhaps when you're working on a new code-based file or analysis or homework assignment, maybe not homework assignment, but for a new class, let's say, if you're a student, you may want to go up here and start a new project and then have that project tied in with your GitHub profile through version control. And then set up all your different files, select which ones through Git Ignore that want to be pushed. And then as you're working on the project, just occasionally push, like commit and push updates to GitHub. And then you don't really have to worry about the file organization on your computer that much anymore. And you're good to go. GitHub's entirely free for new users. It does have like paid methods, of course, which allowed for like more advanced and like enterprise company-based tools. But you can get like shockingly far with the free version of GitHub. It's just a fantastic. I can't speak more highly of the of GitHub service. So I hope I convinced you to use some of these features, and this is how you kind of do some of this stuff in R. Write in the comments below if you think I missed anything, or if there's a feature, or if I said something a little bit wrong. I'd love to learn more from you all, and I hope you have a great day. See ya.